Hey guys, Mr. Gran here. Day 2 of polynomial long division. We'll have 2 videos today. The first one is going to be on this thing using synthetic substitution. So it's really what we did in the video yesterday. It's synthetic division, but sort of a special case, a special way to use it. So let's take a look at this problem. Evaluating this equation for x equals 6. So what I can do is I could plug in 6 squared minus 4 times 6 plus 2, and that ends up being 36 minus 24 plus 2 is equal to 14. Now, what's interesting about this is if instead of plugging it in, I do synthetic substitution for this, where instead of x equals positive 6, I'm doing synthetic division with x minus 6, so that the number here is going to be a positive 6. Now let's see what happens. Let's see if we notice anything. So our coefficients are 1, negative 4, and 2. And the 1 drops down. 1 times 6 is 6. Negative 4 plus 6 is 2. 6 times 2 is 12. And then our remainder is 14. So what you can do instead of plugging in a number into a polynomial, which this one isn't so bad because it's just x squared minus 4x plus 2. I could do that one pretty quick. But if it was a bigger one like x to the 5th, x to the 4th, where there's multiple terms, this can be a lot more efficient to actually work this out by hand. All right, so this is the remainder theorem. I don't expect you to copy this all into your notes, but basically it says this, that if you divide a polynomial by x minus a, the remainder is that function evaluated at a. You could do that instead. So instead of plugging in positive 3 into here and calculating it out, you could also divide it by x minus 3, and the remainder is the same as the answer that you would get if you plugged in 3 for x. All right, so one quick example, doing one of these for x equals 2. Now the big difference here is students sometimes want to switch the sign on this. You would switch the sign if it was division. So I try to tell students, like if I'm doing divided by x plus 2, right, or x minus 2, if I'm dividing by an equation, this is when I change the sign. If I'm given a number, if I'm saying x equals 2, then I don't change the sign, right? So just to remind you, the reason that you would use positive 2 for this is because 2 is the x value that makes this equal to 0. In this case, you're given the x value, so you don't have to figure out the x value that would make the binomial equal to 0. Okay. So all we're going to do is synthetic division. We're not going to change the sign because it's x equals 0. Then we've got 2, 5, negative 1, 7. And bring down the 2. 2 times 2 is 4. 5 plus 4 is 9. 2 times 9 is 18. Negative 1 plus 18 is 17. 2 times 17 is 34, and 7 plus 34 is 41. So P of 2, if we plugged in 2 into this equation, I would get 41. And that's that.